do you say?
Yeah!
Good? Okay, ready?
Let's
Go!
go!
Another countdown from 5.
4, 3, 2, 1.
Great, here we go. Okay, a little round of applause. So that was also known as gun cotton. Raise your hand if you remember gun cotton. Okay, great. Gun cotton was founded back in the early 1900s or late 1800s, and it was discovered by total accident, as is many different explosive compounds. By complete accident. So you can imagine some guy is working with concentrated acids in his lab, and he turns around and all of a sudden, the piece of cotton that he was using to, I don't know, fix his pimples or something, fell in this concentrated thing of acid, and all of a sudden it dried, and then he bumped it again, because this guy was really clumsy, and then some type of flame fell on it, and it burned it. So that's exactly what happened, okay? So this was discovered by complete accident. And the word gun cotton is used for a specific reason. Why do you think it's used? What context do you think gun cotton is used in? Yeah.
They used it in guns, they put it in the back, and then when they pull the trigger, it would make a spark and it would fire.
Absolutely perfect. Great. So gun cotton, as it comes from the name, was originally used in guns as a propellant. So you would light it on fire, it would create a lot of pressure like we showed before, and it would propel the bullet out of the gun. Nowadays we don't use this because gun cotton is pretty unstable and very flammable, as you've seen. Nowadays what do they use in guns instead? Or in older guns?
Gunpowder?
Gunpowder or black powder. And it's much more stable than gun cotton is, hence why it's used nowadays. So, that was gun cotton. Let's try something else. What do you say?
Try C4.
Let's try uranium.
Well, this stuff scares people a lot.
Everything's scary.
I know, I'm a very scared person.
Oh, I know
Okay,
that.
so I have a tiny bit of this other white substance. It seems that all bad substances are white substances. I don't know.
Right.
So, what I have, or what we have up here, is something called triacetone triperoxide, or TATP for short.
Flash powder?
It's not flash powder.
Oh.
It's an extremely unstable explosive compound that's used in explosives in modern times. Fun? Maybe. Not when my face is up here. So, triacetone triperoxide is this powder that we've seen up here. But as a chemical, it's extremely large. Okay? And when we pack a lot of large chemicals close together, it tends to make things unstable. So the littlest amount of energy, whether it be a shock, some type of heat, sound, is enough to combust this compound right here. So, in fact, if you were to take a hammer and hit this powder, it would likely explode. If you were to blast this powder with extremely strong sound waves, it would likely explode. So this stuff is very unstable, and when we make it, we have to do the reaction right away, because we don't want this stuff sitting around and potentially exploding some other day when we're not aware of it. So, let's get Rashawn Lace. What do you say? Great. So this is just a little amount of this powder. Okay. There's like 16 lights up here, and it's ridiculous. Okay, so Michelle's going to simply touch this filter paper with this white substance with a brush. And hopefully it should make a little bit of an explosion. So, count down from 5, please. 2, down, set, hike.
And 5, 4, 3,
Okay, so the really neat thing about this powder is that it burns so rapidly and so fast that there's absolutely nothing left on it, not even a burn mark on this filter paper. All this is a little piece of paper, and it looks completely unharmed, untouched.
Like
So,
it wasn't even there.
like it wasn't even there, which frankly scares me a little. So, what do you say we do a bit more?
What's more?
Tablespoon.
Yes.
Would it not leave a mark if you lit it on your hand?
Sorry?
Would it not leave a mark if you lit it on your hand?
Would it melt even more?
Would it not leave a mark?
Likely not, but I'm not going to try it. Put it that
Let's
way.
try it.
Does Rochelle want to try it?
Because I get to
Okay, so we have
It's such a big pile of explosives.
There's a pile of explosives. Or the
I think it's the first 2 to the left. Okay, great. So we're gonna try a little more. Let's use all of it. This is the rest of it. Okay, so
3, 2, 1.
so did anybody feel the heat on that one? Thought so. And once again, not a single mark on the filter paper. We have a huge explosion? No, because I might lose my job. Just kidding. What's that? Great. So, the little one's gonna, this next one's gonna take So, are you guys enjoying this so far? Good. I'm excited. Okay, so, you guys are gonna laugh at this. This next compound in this test tube is the color what?
white.
Purple.
Which means it's probably what? Dangerous, right? Okay, great. So I'm starting to learn that as well. The more these get pretty dangerous. So what we have here is something called potassium chlorate. Raise your hand if you've ever heard that. Really, that's impressive that you've heard of that.
Unsalt.
Great. Potassium chlorate has a chemical formula that looks like this. Oh, geez, that's a low. Okay. And when we add heat to it, we get a salt, potassium chloride, almost like the table salt that we have at home, and this gas. What is this gas? Great.
Is that a balanced chemical?
Where'd the other O go?
Yes, it is. It's not a balanced chemical equation. Wait, that's beyond what this is. So, in this test tube I have potassium chlorate, and when I heat it up with, let's say, the Bunsen burner, it decomposes into oxygen gas Hey guys, seriously, come on, slow down now.
Dude, your shoes on that table.
So as we heat this up, oxygen
Video.
gas is going to fill in this test tube, okay? We're going to create a pure oxygen
Better.
environment in here, which is going to be great for the combustion of this compound right here. Now, I have here a piece of black substance now. You may find it in a barbecue in the summertime.
Charcoal.
What's that?
Charcoal.
Great. And what is charcoal? What
Char.
is charcoal? What element is charcoal?
Carbon.
Carbon, right? Solid carbon. And as soon as we put carbon into pure oxygen, what do you think we'll get? Carbon plus oxygen equals what? Any ideas? Yes.
Carbon dioxide.
Perfect. Carbon dioxide. Raise your hand if you